Okay, so let's talk about chemical bonds. Okay, so now we're really about to get into a huge part of chemistry with these chemical bonds. Let's get to it. So chemical bonds are forces that hold your atoms together. Okay, so these are the things that are going to keep those elements right together with each other. Okay, because we understand right with that theory that was proposed atomic theory, right? The elements aren't changing, but the way that they are arranged with each other, that's what's changing, and that's due to these chemical bonds here. So once again, bonds are forces that hold these atoms together. Now, we're going to talk about two types of bonds in this general chemistry 1 class. There are other types, but we're only talking about two here. We're going to talk about covalent bonds and ionic bonds. Okay. So covalent bonds. A good example of a covalent bond are is like water. Water has covalent bonds. Okay. So what exactly are covalent bonds? So covalent bonds occur between two or more nonmetals. Okay. Two or more nonmetals. So we think about water, right? Hydrogen and oxygen. These are two nonmetals. Okay, and since they have these bonds between each other, they have covalent bonds. Now, specifically, covalent bonds, they share their electrons. Okay, so they share their electrons between each other. All right, and we'll see how that breaks down when we get to Lewis structures. But right now, I just want you guys to know that covalent bonds, they share electrons between each atom. Okay, and once again, because they're sharing these electrons, we can only see covalent bonds happen between nonmetals. Now, this is different from ionic bonds. Ionic bonds, all right, we're going to see a bond between a metal and a nonmetal, okay? And the key thing with ionic bonds is that they actually transfer electrons between each atom, okay? So they transfer electrons. They're not sharing. Somebody's giving electrons, someone's taking an electron. All right, there's a transfer of electrons going on between this nonmetal and metal. And we've been talking about this, right, briefly, right, with the ions effect, but we really see that in play with ionic bonds, right? Ionic bonds, guess what it has in it? Ion. Okay, so basically we have ions forming these bonds with each other, right? So that's what we really see with these ionic bonds. Now, a great example of an ionic bond is sodium chloride, right? Your normal table salt. Okay, so if we look here, and this is really what's going on with these ionic bonds, right? Making these ionic compounds. So say we have sodium metal. So this is sodium metal, what it normally looks like, a typical solid, as we can see the structure here. And then we have chlorine gas, right? We mentioned that it's this pale green color. And we can see that gas, right? We understand they're moving around, they free. Now, what's actually happening, right, with the transfer of electrons? Okay, because what we're going to realize, right, with these bonds, and we got a whole unit dedicated to this, y'all. So, we're going to talk like in great detail about bonds. But what we're seeing here is that these bonds are forming with the electrons here. That's the key thing here. Those bonds are forming with the electrons. So let's look at this one. Let's look at sodium. So sodium we understand is a metal, and we know that metals love to lose electrons. They love to lose electrons, right? To become those cations. So the neutral atom, in this case, that neutral sodium atom, right? And we see here, right, as I mentioned before, we went over this. We need to understand that if it's neutral, right, you're going to have the same amount of electrons as protons. So sodium has 11 protons, so it's going to have 11 electrons. So we have 11 electrons here. Neutral, neutral. Now, sodium, being a metal, loves to lose electron. So bam, let's knock this electron out, right? And once sodium loses this electron, guess what's going to happen here? It's going to become a sodium cation, right? So this neutral sodium becomes positive, right? It just lost an electron, right? So it's more positive because it lost that negative. So now, right, that 11, it no longer has 11 electrons because it's been lost. It has 10 electrons. So now this sodium cation has 11, right, protons and 10 electrons. So it has a overall +1 charge. And this is what we see here, right? This is what we're seeing here, this sodium +1 ion. Okay, so once again, remember the ions have a charge. So now this is not a neutral sodium atom, this is a sodium cation. Okay, now what's happening, right? What is going to happen to this electron that's being lost, right? Well, let's look at our friend over here, chlorine. Chlorine, right, is a nonmetal. And we understand with nonmetals, they like to gain electrons. So right now, this chlorine atom is 17 electrons, right? And remember, if you don't know, chlorine has 17 protons, right? So remember, if you're neutral, you're going to have the same amount of electrons as your protons, right? At 17. So let's talk about how it's going to gain an electron. Well, we understand that chlorine gains an electron. Where does that electron actually come from? Well, our friend here, sodium, just lost the electron. And that lost electron will be going to our chlorine, right? So it's going to gain that electron here. And when it gains that electron, right, what do we see here? An anion, okay? So now our chlorine has become an ion, in this case an anion, because it gained that extra electron. So now we have 17 electrons, but it becomes 18 electrons. So if we just think about math here, chlorine has 17 protons, but for chlorine ions, in this case, this -1 charge ion, it has 18 electrons, right? So now we have more negative. And now we see the -1 charge here. Okay, so now that we have this sodium cation, which lost an electron, and this chlorine anion that's gained an electron, this is where those opposite charged ions will come together to form that ionic bond. Okay? And when they come together to form this ionic bond, they form what we call a crystalline lattice. Okay? So they're going to form this crystal. And that crystal is sodium chloride, which we see here, everyday table salt. So this is what's occurring, right, with these ionic compounds, okay?